Very good. How are you, David?
Excellent, thank you. It's really good to have you along. It's going so fast. It seems like there's such an exciting build-up, and we kicked off yesterday at 9 a.m. It's been all go ever since, and now we're on to our last 2 workshops of the whole of ClueCon in February.
It's easy to be successful, isn't it?
It's made a whole lot easier by having high-quality speakers delivering high-quality content, Lorenzo. And you're our second Lorenzo of the day, I'm very pleased to say. But before we carry on, how's Chile? Haven't seen her for a little while.
She's actually roaming around here. Everybody's good. Thank goodness. Excellent. We're all doing good. Thank you.
I'm very, very, very pleased to hear that. And are you joining us? Well, let me ask you, where are you joining us from, Lorenzo?
I'm joining from Valencia in Spain today, where we have one of our offices. So I'm here working. I don't miss the snow in the Netherlands.
Well, yeah, that's great. I was going to say I traditionally associate you with the Netherlands, even though I believe you're an Italian man. I've met you most in Amsterdam, and always
that's where I usually am, indeed.
Those interactions, and of course in the States for various reasons as well. Anyway, now let me ask you: does your presentation give as you get into it, does it give a bit of an overview for HOMER for those that might never have come across it before?
Yeah. We're gonna ramp up from 0 to the latest things at a variable rate. So yeah, I mean, there should be a little bit for everyone in there. Whether you already know and use it and you want to know, what else you can do with it, or if you just want to get started with it, I'm going to go from the bottom up.
Brilliant. Okay, well, thoroughly looking forward to that. And it wasn't that long ago we did a ClueCon cafe together and looked in depth at some of the newer stuff you'd got in there. So that's exciting too. And I can't let this opportunity go without saying another quick hello to Alexander there, just underneath you. Good to have you along as well, Alexander, part of the project too. So good to see you there. And I will hand over to you, Lorenzo. Yeah, hello, Alexander. We'll share your screen and it's over to you.
Wonderful. And Alexander, of course, will be joining me towards the tail, of course, when it gets to Q&A and interesting topics. He's the best, so he's here to help me.
Pleased to hear that. All right, we'll get your slides up on the screen then and move forward.
Perfect.
Now, have you shared your slides with us, Lorenzo?
Yeah, I'm sharing right now.
Okay.
Should I share again?
If you turn on your screen share, I can actually see it. In fact,
let me do it again so that you have a fresh one.
Yeah, hold on. I can give you a roll there. Okay, yeah, I can see you sharing it there. Let's just... Okay. All right.
Yeah, that's me. All right. So first of all, thanks everybody for joining. It's really good to see all of you here, and hopefully you're going to have something interesting for everyone. So whether you already use HOMER, as we said earlier, or if you're just getting started with it, we're going to have something for you. So this is going to be the HOMER 7 HEP workshop that we're about to get started with. Brief introduction. I'm Lorenzo Mangani. For those of you that don't know me already, I'm the CEO of QXIP HEP, which is the company running the HOMER project as well as other projects. Started with Alexander Dubovicov, who's also in the chat, and happy to help you. I'm a sound engineer by trade, turned voice engineer, definitely open source lover and developer. QXIP is our company, which is based in the Netherlands, in Amsterdam. We also have an office in Valencia, which is where I am right now, where we run our web development front and some other feeds. And our specialty is exactly into VoIP and RTC monitoring and troubleshooting. That's our trade. That's what we do. That's what we like, and what we've been doing for the majority of the last 10 years. We're involved with a bunch of other projects that are necessary for the participation and understanding. So we all have different backgrounds at the company, but we try to put all of our experience together, building HOMER. For those of you who are not familiar with it, HOMER is a troubleshooting tool. So it's a time machine for packet signaling metrics events in a very generic way. It's 100% open source, of course. robust. It's been in production for a long time. We have had many versions overlapping each other. 7 is still the latest one and the one that's receiving the majority of innovation. And yeah, it's a framework, really, not just a project that's designed to make it easier for people to track what they care about, to help with troubleshooting and to some extent exactly monitoring. It started as a SIP-only project many years ago. Actually, FreeSwitch was the very first platform where we implemented our HEP encapsulation protocol, which makes it all possible. And since then, a lot has happened. So today it's a little more generic and complex platform. Well, we're getting to that. The project is used and trusted by many companies in production. And we help them with the engineering, deployment, etc. That's how we also sponsor the project. But the primary goal is exactly troubleshooting and making our users' life as easy and lazy as possible. So HOMER is not like a fun platform to use. Normally, when somebody's gonna log into it, there's a problem. So it's like a colleague 24/7 sitting there tracking everything, hopefully standing by, ready to answer the important questions. It's designed to be agnostic in general, so we deal with just anything that you throw at it nowadays. But as said, the core integration is the one based on HEP. So the HEP encapsulation protocol is natively supported in a bunch of platforms, of course, FreeSwitch, but OpenShips, Kamailio, Asterix, Dractio, but also RTP Engine, RTP proxies, and a bunch of other platforms supported internally, which means that they can use it natively to talk to our platform. So no third-party tools, no weird hacks to make things work, and also a lot of engineering capabilities built in. So today in the workshop, we're going to go through a few of those things. The point is to give you confidence. So hopefully at the end of this, you have a clear idea what you can do with this or what else you can do with it if you already use it. So we're going to just have a few brief mentions of how you can get it up and running, how you can configure the HEP clients that make it all possible. So the data feeds that send data into HOMER, be it native ones, so FreeSwitch, OpenShips, Kamailio, RTP Engine, etc. We'll see also a few custom ones and a few ways to attach, let's say, external data feeds to the platform, if you will. We will also see how you can validate it, basic of search, and then we'll see where we want to go together with this. So if you do want to run the workshop, I mean, it's possible you can take the things from the slides. I don't expect anybody to do it, but if you want to, all of the instructions and things I'm going to refer to are available on our GitHub. All you need, of course, is a problem to solve, so a VoIP or real-time communication infrastructure of some type that speaks protocols that we can capture, because our empty HOMER is totally useless, of course. Understanding, of course, of SIP, VoIP, RTC in general helps, because being a troubleshooting tool is just going to help you get to the data, not necessarily solve the problem for you. Fresh system, so HOMER can be very easily installed on a fresh Debian or CentOS system, 10 or 7, or a VM, or within Docker. We also have some other methods that we can discuss later. Having traffic, of course, again, is the primary thing here. So if you're going to be using it, remember, empty means nothing. If you have questions, of course, you can ask now, or you can ask in the chat. Alexander, Ax, Yachan, and a few of the other guys from my team are there, so they're also going to be happy to clarify things. If you see something, feel free to interrupt me as well. I don't mind. So, little warning, HOMER, unlike, let's say, the previous HOMER, is very dynamic now, meaning that you can assemble different things with it. It's a little bit intimidating at the beginning, especially if you don't know yet what you want to do. So the best way is to mold it on top of the problems that you want to solve. You can connect to many things. You can use different ways of collecting data. Don't worry, it's all about choice. So as we go through the presentation, hopefully you get a better idea of what those choices are, how to use them. The ecosystem is quite large, again, because exactly almost nobody uses all of those things at the same time, but we have to be flexible. So we have a bunch of data sources that can send natively data into the system. And we also have a bunch of backends and databases that we can write, let's say, HOMER process data to. So be it the raw packets data or time series or logs that can go to a bunch of backends depending on the customer, the user wants to do. Our ideal world is the one where this fits into your existing ecosystem. So if you already use any of those things, great. We just want to attach to them and give you more data to work with. That's the spirit. So since that's plenty, today we're going to focus on a subset of this. So during the presentations, you will see some of these elements that I've listed here. And now we can connect them to the system. But first, a few notes on installing, so getting HOMER up and running. If you are going to do this on a real system or real host, it's really, really easy. All you have to do is clone the HOMER installer repository, following the 3 commands that you see here. The bash installer is going to start. We'll ask you a few questions here and there, but basically it's going to spin up an entire stack all in one on a single host. Once you understand it and you get familiar with it, you can, of course, move those hosts together if you want to have your database on a separate host, or you want to use external time series database storage and so on. That's all possible. But this script will get you started with an all-in-one setup that you can just use and send traffic to. If you prefer to use containers, we are pushing container builds every day. So with modern, let's say, Docker version and Docker Compose, you can get started. We have a couple of main flavors here, but we actually have more on the repositories that you can find, either using InfluxDB for time series or Prometheus. And that's the main, let's say, difference that we have. The rest is pretty much the same. If you get it started, you will see a few services will spin up. So HOMER is actually made of as many components as we choose it to have. The baseline is, of course, a capture server, in this case, Amplify server. The HOMER web application, which serves the UI and the API, a database, Postgres in this case, and a time series stack. And here you can see it's the InfluxDB tick stack. So influx, telegraph, chronograph, capacitor. You can have Grafana on top of it. You can use Prometheus instead. Again, there's a bunch of choices. So when we run this script, the important components that we install as part of the HOMER setup are the following. So we have Amplify server. Its job is to capture the packet. So this is the HEP receiver where all of the agents send traffic to. It has a few configuration items we'll see. HOMER app, again, is providing the API, the UI, and a bunch of other things related to actually using HOMER, putting in place correlation, and joining the different data sources, etc. And Amplify is our vanilla capture agent. So this is the passive sniffer that you can deploy on any system. Just run it. And it's statically compiled, so easy to just bring on board and run. And it can just capture packets, correlate them, RTP and SIP and RTCP, as well as logs if desired, and send them back to HOMER. So this is the simplest passive agent that you can use for a system that doesn't have app, or whether you don't want to use the built-in capabilities. HOMER HEP is as its configuration directory in USR local HOMER HEP. This is when installed with the packages that we provide. Again, all of this is done automatically if you use the script, but you will find also manual instructions, which are a bit complex, but possible to follow. And it offers a few key settings. So the how it's going to serve the UI, so the HTTPS settings for the user interface and the API, database config, and then InfluxDB, Prometheus, Loki, Grafana config for the native integrations, meaning that this web app can talk to those natively, either in and out, depending what they are. Authentication settings for local, LDAP if you want to connect it to external authentication, system settings, etc. And the application can also act as a HEP relay for sockets and web sockets. So the application can actually even receive traffic. We use this for a few features. Sending data from browsers, statistics, for instance, that's one. But also just importing pickups or things that the UI can handle. So the UI can actually read pickups, transform them to HEP, insert them. So direct import is also possible. And then last but not least, external decoders. So we have our internal decoders for protocols that we support, but for everything else, we can pipe through things like T# or other tools that can dissect and return data for us. Amplify server, capture server, can listen to multiple sockets, typically UDP or TCP, talks to the database, so it's a bulk inserting into the primary database the packets that it receives. It can rotate the database as well. It can talk and push data to Loki, Elasticsearch, HEP targets, and a few more. It can tag traffic, so you can see there we have a target IPs and names. So here we can define a simple way the elements that belong to us that we want to be uniquely tagged and searched. We can extract IDs for identifying correlations. So we can have multiple identifiers. If found, they will be extracted to correlation ID. We can discard methods that we don't care about, and we can handle custom headers. So all of the basics are there. And then Amplify, I said, is the agent. If you already use a HEP-capable platform, you probably don't need it. But if you want to do everything passively, this is the agent. You bring it on, you define where it's going to listen, where it's going to send, you give it an ID, you choose which protocols you want it to handle, and off you go. So it's a really quick way to get everything up and running. If you follow any of the installations, you'll find HOMER reachable at one port 9080 by default. You can log in with a default admin unless the installer changes for you. And you will basically land into an empty SED dashboard where you don't have any data. So the next thing you want to do, if you have real traffic, of course, we'll plug some agents, but there's a good way to test and validate the setup using HEPGen. HEPGen is one of our many little tools that orbitate around the HOMER project. And this one can basically simulate data sources. So it can simulate a system capturing data and sending out HEP packets. This can simulate SIP, RTCP, RTP statistics, logs, and a bunch of other events. Basically, it's also our CI testing tool, how we validate if something works or it doesn't. So if you install it with NPM and you run it against your setup, you get some inserts that you can use to validate and make sure if everything works. So if you do that, you can search in the last hour in HOMER, and you will get some results. When you get those results, we can open them and we can see if they work. We should get a bunch of tabs populated, showing us respectively the messages, so shark view signaling, the call flow with all of the protocols that we have intercepted, QoS metrics, logs, and the ability to export, of course. So all of those tabs should be filled if you run this test, which means that your system is ready to go. So we can send it something real. While you're in there, you can go ahead and configure aliases as well. So for your systems, you want them to be recognized in the UI, and you can create aliases from the settings menu, alias. You can create as many as you want, and as in this example, they will be tagged. So every time a packet comes or goes to one of those elements that you have defined, it will get a name and some styling as well. So this is the system so far. So we have a collector up and running, in theory, connected to whichever backend you have decided. We just sent it some test traffic with HEPGen. We see that it works, and that's really good for a demo. But now let's get real. We want to send this thing some real traffic. And how do we do that? So let's roll back to the native HEP features of the platforms that we support, free switches first, of course. We have a link to the wiki. So in the wiki, we have dozens of recipes for all of the systems that we support. So this is just to illustrate what's involved, but you can really go always on the wiki and find the detailed instructions for hopefully a next to copy-paste experience. So yeah, I anticipated myself here. So let's configure free switch to trace to HOMER using the HEP protocol and the built-in features. So to enable the HEP feature, the first thing we do is loading and defining the capture server parameter in the Sophia config. So capture server parameter will have a few fields there, where the first one is the target. So we're going to use UDP to send to an IP and port representing our capture server. Port for HEP is always 9060 unless you change it. So the only thing you would have to adjust there is the actual IP and open the firewall ports. We're going to use HEP version 3. This is the minimum that we require for HOMER 7. And we're going to give this instance a capture ID. The capture ID is going to be useful to tell it apart from other instances. So if you have 100 free switches, you want to know which one was sending the packet. So you can use this in any way, fashion. It's an integer parameter that you can populate. Once this is done, we can enable and disable the HEP agent globally. So we can globally switch it on and off so that it can operate. If we want to be more specific, we can enable and disable it for specific profiles. So if we want to only mirror, I don't know, our public-facing parts or whatever else, we can fine-tune it this way. And pretty much that's all there is to it. Maybe the only other mention would be to set a correlation header. This is going to be useful if you want to be lazy and you want HOMER to do everything. It needs a way to stitch back-to-back user agent legs together. So when the call ID changes or everything changes, we want to have something. So in this example, we just inject a simple XCID that we can then configure Haplify server to use. So the ALEG ID XCID will be extracted and used as a correlation header every time it exists. And this will allow HOMER to basically transparently correlate legs for you. So you can choose either one of the back-to-back user agent legs, and they will find each other within the system. On top of that, so this is the, we're sniffing off the car, but we can also attach HOMER with HEP pipe to the ESL socket. And from here, we can basically get logs out of it and link them in real time. So from the ESL socket, we can subscribe to the events that we care about. And HEP pipe or Pastash can turn them into HEP packets. So they will be converted, most of them, to HEP type 100, which is the one that we use in HOMER for attaching strings, JSON objects, logs, or whatever else to a session. So they have in common basically a correlation ID. It's going to say this log talks about session ABC123, and it will be attached. If we receive RTCP events from ESL, we convert them to type 5, which is dedicated exactly to RTCP, and it will be displayed as statistics on screen. And that's about all there is to it. So if you enable those parameters, if you want them at your HOMER instance, you will see the traffic appear in real time. So you make a test call, you find it. If you have any questions about this, Alexander, Ax are on the call, and they can help you in the chat if you have something specific while I roll forward, or you can just log them there and we can discuss them at the end. Similar thing for OpenSIPs. Next, we're just briefly running through it. OpenSIPs has a really mature HEP implementation, which not only allows you to mirror stuff, but also to make up some HEP types on the spot. So you can generate something that even doesn't exist within OpenSIPs. You can even use it as a HEP proxy itself. So you can send HEP to OpenSIPs and then fork it, send it to multiple HOMER instances, useful in the case where you want to build a complex or redundant cluster, the same way that you build, let's say, your voice clustering. You can do it also for the monitoring. In OpenSIPs, we can monitor, of course, everything that goes through normal sockets, but also REST queries, Xlog messages, and commands. So literally everything that the platform is doing can be mirrored through HEP. The steps to configure it are pretty simple. You load the proto-HEP and tracer modules. In the config, you configure them similar to what we have seen before, a target, IPM port, transport type, version of HEP, and then the tracer takes care of defining basically a route for it. This is an example for it. So it can operate in multiple ways. This is just a very generic one. And again, I think Alexander can answer any more specific question you might have in terms of how you use it, or you can refer to more specific presentations we did in the past about this. But same thing, you choose the methods that you want to mirror. So either all of them, CP, Xlog, REST, or only some of them if you choose to do so. And that's basically it. So you can also complement those with lookup. So if you have REST queries or Xlogs, those can also be routed. So you can see what the network was doing, which packets were going back and forth, but also what the system was doing before and after. So the decisions that were made, the logs and everything will end up. And same thing as above. Feel free to log any question you want. Camaillio, next, a very similar example. This is for 5, but we have instructions for previous versions as well on the wiki. You define that you're going to be using HOMER. You load the zip trace module. You configure the basic parameters. Once again, same thing for zip trace. We're going to send it to a specific target, IPM port, and we can choose the way or the flags that are going to be triggering it, after which we can just use them in the route logic. And here we have a few examples of how you can trigger it just for capturing everything or some specific events, or to change what the system would do by default, insert custom correlation headers. So if you want to force something to be correlated with another leg without inserting any ID in the actual signaling, you can do it this way. And of course, you can send also logs with any action that you might want to appear as part of the troubleshooting. So again, these things appear in sequence. So in the call flow, you would see invite, internal log, I received an invite, I want to authenticate it, and then the 4.7 go back. That's the idea. Of course, the proxies can also be connected to media proxies, such as RTP engine, RTP proxy, and those, thank God, also support HEP or more than God, thanks to their developers, which support the protocol. So how do we get the RTCP statistics and sometimes even the control protocol into the troubleshooting using HEP? So for RTP engine, just a few flags that we should enable to allow type 5 RTCP reports to be sent back home and see what the proxy was passing back and forth. Of course, it doesn't produce any by itself, so all of those would either come from the user agent devices or the back-to-back user agents. And for RTP proxy, similar thing. We load the RTCP HEP module, which must be compiled when you build the project, and then the usual parameters: target IP, capture port 9060, UDP TCP, and a capture ID, which again is used to identify what's what, where those statistics were coming from, or anyway, which part of the cluster was generating them. So the system so far. Now we have plugged a few or all of our systems. Everything is going inside of the HEP capture server, goes into the database. The UI and the API can talk to it, can communicate back and forth. Some of these data will become time series. Some of them will become searchable tables. For you, it will be the same. So the UI should unify the experience, and it doesn't really matter which one you use. So making a few test calls. If you have a test set up, or if you have a real one, you will find traffic, and you can make sure this actually worked. So you should see all of your SIP sessions appearing. You should be able to select them, display the various tabs that make them. So the messages, the flow, you should see the logs. This is an example of what we see when we attach non-SIP events. And again, this could be anything. It could be something that you make up. It could come from a disconnected system. So you could have the capture happening free switch, and you could have your own script or your own whatever send additional data, as long as it's a correlation ID that will get stitched together for you. And if we have them, RTP and RTCP statistics will be visible in the QoS tab, which can be switched between different types. I'm going to show you more about this later, but we can take a look at the estimated MOS, packet loss, jitter, inter-arrival jitter, bytes exchange, packets exchange, etc. Whatever comes from the device. At that point, this data gets also forked into time series. And this is important because if it's true that in HOMER, of course, we can see them on a per call basis, in the time series backend, we can see them as a whole. So we can see if a system, as a single call losing packets and it's just, a fluke, or if all calls on a specific system are actually presenting issues, if all users are experiencing them, etc. We can all look at those things, let's say, from the top, so that we can kind of figure it out. If you made it this far, or if your system is already at this stage, well done. This is basically the baseline of a HOMER system, so what we consider to be normal. And we'll get into more detail as of a few of those things if you want to in the next part. But now I wanted to touch on a few advanced topics. So this is what basically everybody's doing with it, but what other things can we do? What other configurations can we introduce? What other systems can we talk to is just next. So one of the first things that need to be clear, and this is probably where Alexander can also be helpful later if needed, is understanding how correlation can be configured in the platform. So some of the systems, as we have displayed earlier, like some proxies, can automatically send correlated data. So they can send data from an A leg, and then they can create a second leg, and they can choose to inject the correlation ID directly in a header. So the packets can come basically pre-correlated, and the system has to do nothing. And this is the case for a system you control. But in the reality of things, you're going to have a number of systems talking to each other, and multiple methods are going to be at play. So here I have a little diagram of what usually happens. So let's say we have 3 legs, where the first leg has a call ID ABC123, and then it gets forked into a second call ID. And in this case, this could be an example that we have seen earlier for free switch. We're going to inject a X header. So we have a XCID header that carries the original call ID. This way, the system can passively, let's say, determine the correlation between those legs. But we can also have additional legs that are injected from outside. So it could be the case of reports that we attach to a specific session, logs that we can attach the same way, or RTP and RTCP statistics. Everything works the same way. It carries an identifier. If this identifier matches something else, it goes through the pipe. So all of these calls will find each other no matter which one you start from. You could start from the log and find the B leg, and the B leg would find the A and the C leg by itself on a properly configured system. This is what you would expect. So kind of an end-to-end lazy mode presentation of all of your data at once, no matter where you start. So it doesn't require the user to be aware of that. How does it work behind the scenes? In HOMER 7 is using correlation mappings. And here I have a couple of basic examples. If you want, we can get into more detail. But this is how we can take an element from a session, so a source field. Let's take a call ID, and then let's compare it against something else. So in this case, we're looking and comparing call ID to session ID, which is the correlation ID, and vice versa, taking a correlation ID of a packet and looking for a matching call ID. A simple way to look back and forth between two different headers that normally wouldn't be correlated. You can also see we have a lookup range array. This allows us to shift time back and forth. So in this case, we say go 300, minus 300 seconds and plus 200 seconds. So we can also find something that happened just before or just after, as it should be, right? For connected sessions, if you create a new leg, probably there was something happening just before. The same thing we do to find correlated events. So lookup type 100 is for logs. So we take a call ID and we ask the system, are there any logs that match this identifier in the database? Or same thing for RTCP statistics, which are HEP type 5. And this is how we create the tabs and the one-click experience that you see with the correlation. So clicking a single identifier, finding multiple legs, multiple reports for each one of those legs, etc., etc. And as we will see, we actually can do much more than this. If you have questions or if this is of interest, log it in the chat so that we can get into more detail. Now, this is another hot topic that we see a lot of potential for. So all of the data that we have seen so far was in the system, right? So we have captured it. It was either sent to us by a cooperating system, so a free switch, or an OpenSIPs instance is sending us HEP packets. Everything else up in our database, and that's how we search it. But what if the data that we're interested into is not in our database? What if we only have a piece of the puzzle, namely the SIP session, right? So we have our SIP session in our system, and it only knows what we have captured, but we have more data laying around the company or the infrastructure or in the neighboring systems. And this is why we made up HEPSUB. HEPSUB basically allows you to write external plugins to HOMER that subscribe to it through a PubSub API. So a HEPSUB agent can start up, can connect to HOMER using an API authentication token, and can offer to resolve additional data. A few examples: HEPSUB for APIBAN can be used to look up if any of the IPs in our sessions were banned. For CG rates, we can look up if any CDRs or billing was generated for one of the sessions. RTP engine, we can look up and download any pickup recordings that were generated during the call. VoIP monitor, same thing. Was anything recorded there? We can take it out. CloudWatch, was any event logged into AWS CloudWatch, Elasticsearch, and so on. So these are just a few examples that are actually already on GitHub, and you can spin up and customize for your purpose. But you can attach it to your own API, right? So you could take a phone number, make a HEPSUB agent of your own that queries your company's API and returns the customer name. This is John Smith because this is their number that we sell them and it's in our database. Right? So this type of stuff is extremely powerful. How it works exactly as described. A user, this is the example for APIBAN, user selects something. We have configuration items in the mapping that decides how everything is done. I'll show you in a second. So we can take some details from the sessions that we have opened, in this case, all of the IPs that we have seen in the flow from all of the sessions that we have correlated, and we can do a lookup. APIBAN gets cached by this type of plugin, so we have local results that expire. If we don't have any, we can make a real query, and we return the database. So for this IP, fictional one, 60, 53, 194, 169, this is not blocked anywhere, so we can trust that it wasn't part of APIBAN results if that's what we're using. Another example that I mentioned for RTP engine, if we have RTP engine with recording enabled, in real time when we open a session, HEPSUB agents can query RTP engine instances metadata and find if they have recorded anything, and they can return the details of either the pickup or the wave And if you customize them enough, they can even play it back. So they can provide a playable waveform. So you can have actual recording and real-time, let's say, connectivity with those elements. How it works, as mentioned again, in HOMER 7, everything is available through the UI. So this is another mapping setting for HEP sub. And for each type that we define, we can choose what we're going to send those agents. So when an agent subscribes for the RTP engine type, we're going to send them back the call ID, from time, and to time of all of the sessions. If it's API-bound, we're going to send them an array of IPs, source and destination, etc., etc. For your own, you can take literally anything that you want. So you can take a X header or something else that you have injected, send it to your own HEP sub agent, do something with it, return data. The data is displayed directly in the UI. So it appears next to everything else. It's even displayed in the flow, and it just makes sense, especially if you tag it right time-wise. It appears exactly where you would expect it to make sense. Another cool way to get more data is HEPjack. So TLS, when you have a system that's properly configured, it's not, and it should not, be possible to sniff it passively, of course. And so what do we do is a question that we get asked quite frequently. What are you going to do in the future? The route we took here is a little bit experimental, but it actually works. We attach and we inject code into the library. So using the Frida framework, we can actually inject callbacks into the libSSL or any library really out there and have callbacks. So that actually we don't even look at the network. We let it encrypt everything and stay safe. We don't break our own encryption. And we just get the similar way as we do from your proxy and back-to-back user agent with HEP. We get them from HEPjack, which is, again, attaching to callbacks of the library, and it can just give us in the clear what's been encrypted and decrypted. HEPjack will turn it into HEP, of course, and it will send it to the platform. And there you have it, just another way to sniff something without breaking the encryption outside, of course, of your security perimeter. So if you do it on the same system that you control, it's quite safe. Still, a hacky approach, but Frida is a very mature framework. So as far as I'm hearing, it doesn't create any major hassles as long as you're using it. What else? Logging agents. So we've been talking about packets. We're talking about external data, PCAPs, and things that we can find. But what about non-SIP data that we want to inject into the system? Or what about closed platforms that don't really provide like a public way or a public integration for sending data? Converting logs to something that's meaningful, or taking syslog events of an SBC and converting them back into SIP. All of those missions are quite normal for us. We find many scenarios where we just have to get creative. And this is what Pastash is for, named after pasta asciutta, of course. This is the spaghetti army knife of the stack. With Pastash, we basically have a flexible pipeline made of input, filters, and outputs that we can combine to any extent. So we can just open a normal socket, WebSocket, TCP socket, rather than just read some files, rather than attach to a queuing protocol, get data into the pipeline one way or another. Then we can have this go through filters, and we have a bunch of them, many of which are actually customized. So we have filters that are specific to SBC vendors or format types. So we can take audio codes logs and turn them back into SIP signaling. Same thing with Sonus and Ribbon SBCs, Avaya, Cisco, etc. So we can take data that's native to a platform, transform it into a format that we can be compatible or we desire, and then ship it out in a different protocol. So in the majority of our cases, we take some type of custom logging, obscure format, something. We reassemble it using a filter, which can be either generic. We have like dozens of generic functions to transform and adjust data, or you can write your own processor like we did for many of those SBC syslog reassemblers, and then ship it out the way you want. In most of our cases, it's going to be HEP. So we're going to mimic the original system so that we can get TLS packets, specific logs, or things that we wouldn't be able to just passively sniff into our monitoring stack. Super, super flexible. So flexible that we can actually use it also for browsers. This is part of our FOSDEM presentation from a few weeks ago. But Pastash can also act as a socket to receive data from agents that run inside of browsers. So from secure WebSockets, we can actually have a browser extension talk to the stack. So we can get remote console log forks, RTC statistics, or see what the hell the browser is doing with the media that we send it or that it's sending us, see if the problem is there, and see it in our platform, either as app logs or depending on what the signaling protocol. If it's SIP or WebSockets, it's super easy. If it's some type of WebRTC, you're mostly gonna end up with statistics that you have to stitch together. So we made a little bit of a browser extension, which is nothing super original. It just puts together a few tools that we necessarily needed to use. So again, the core is getting RTC stats, console log, events, and everything that you care about back into the browser. Since we were at it, we tried to make it secure, so we decentralized it. Actually, this is decentralized, so you can generate a unique token on the Hyper network, exchange it with a customer, they punch it into the extension, and it basically gets an end-to-end encrypted peer-to-peer tunnel between the customer's browser and your recipient, which could be anywhere, on board or even on your laptop, and it gets you the logs that you care about. When you get them, they look something like this. So you get the raw browser stats, if you will, and you can convert them into time series, look at them inside of HOMER or anything else that you want. Sometimes you can even bypass HOMER for this, actually. So some of our tools are so flexible that they can be used also with other platforms. And there's a lot more. So, these are just a few interesting routes. But again, implementing HEP on a bunch of systems or supporting your own, understand mapping correlations so that you can mold them on top of your platform, make the dashboard, the search tools, the alert of your dreams using the time series that we generate, do integrations with Loki, implement external data lookups, get logs, browser, WebRTC events, and we support also Janus and MediaSoup events directly into the stack. We have a HOMER view component that you can use to integrate all of this data in your customer portal. So you can have the pipe dream of having people self-troubleshoot their own stuff. This is something that we do with many vendors. Telnix is one of those that took this route, and we work together to provide this to their users. Or you can just go ahead and design your extensions, your protocols, your widgets. It's an open system. And by the way, since we're talking about it, this is actually how it looks. When you log into HOMER, you can normally end up in this default dashboard that you can customize. On the left, you have the search form. Search forms offer as many columns as a protocol definition has. You can customize them. So for SIP, it will be all of your headers, but you can add custom ones, or you can make up an entirely fictional signaling protocol and just make a mapping for it, make it searchable. The search results can be the same thing, sorted, customized, the results, the columns, and everything else depend on the mapping. Everybody can make their own favorite dashboard look the way they want to work, right? Some people will care about the network part, some only about the signaling. So everybody can hopefully make themselves home. When you select something, you get, of course, the full packet reassembled. So the agents are in charge of reassembling UDP and TCP for you, so that you will know if they were fragmented, but you don't have to deal with it. So in the UI, they are reassembled. If you choose a session, we'll just show everything for you. So that's the system I was talking about, the correlation. So letting you be lazy, getting all the data at once for you. So sharp view, all of the messages, distance between them. Of course, you can look at all of them. The flow. And the flow, as you can see now, it comes with more types than just SIP. So multiple sessions can be displayed at the same time and multiple protocols as well. You can choose them from this top right funnel menu, where you can choose how data is aggregated on the screen and which protocols we're going to be displaying. In this case, we have SIP, RTCP reports, and logs, and we have multiple sessions. So we can deselect, select what we want to see, just narrow it down to what we care about. And everything, if well timestamped, appears just where it should be. So we get a request, we get what the system was doing, we got a response, and everything hopefully makes sense. SIP normal, but here's another example, RTCP. So in this case, one of the proxies or one of the systems was also forwarding RTCP to us. And we can display the full original packets in the flow. So you can see exactly where they were placed between, the call being connected and terminated. Analyze them and take a look at them, of course, also from a statistical point of view. So we display here the packets, the octets received, higher sequence number, calculated MOS, inter-arrival jitter, LSR, packet loss for whatever we receive. You can also have multiple sessions. You can also have RTP statistics if you have one of our licensed analyzers that actually look at packets and calculate everything on the way. So there's a lot in there. And of course, the logs. So in this case, as I told you, HEP logs can be natively sent. These are some free switch logs that could either come from system or ESL or any other way you want. External CDRs can be injected. If you want anything to appear when an engineer is investigating, you just send it this way. HEP sub, which again, as we mentioned, external lookups, everything appears in here. If we did a lookup and we get some type of response or data, it appears directly there. And the Locky integration, which is one of many that we're maintaining. So if you also have deployed Locky and you're sending any data into Locky, you can directly query it from HOMER dynamically. So we prep for you a form which already contains the call ID, but this is customizable. So it's actually a preference. You can choose what's the template that we're going to create just to get you the data. Last but not least, of course, exporting everything. So you can export the data that you're looking at as PCAP and text. Of course, this is not going to include the logs. You can export the call flow, or you can share a link. Share link is really useful because it gets the next engineer onto the same call without knowing how to find it. So they don't need to know the time range, the time zone, the user, whatever. They just get a link, they open it, and they're back exactly where you left it. Last but not least, time series. And this is really powerful. In HOMER 7, we have a full two-way integration with Grafana. So all of our data ends up in backends that Grafana masters. And the HOMER UI, rather than reinvent the wheel, of course, it has its own widgets to display data, but it's integrated with Grafana. So every widget that you create in Grafana, or even an entire dashboard, can be synchronized simply by the integration. So we create an authentication token of Grafana, we configure it in HOMER, and then HOMER can query, can find the dashboards, the widgets, and it allows you to just use them freely in your deployment, basically. So we try to make it as easy, as native as possible, so that you don't have to reinvent the wheel, you don't have to have two systems, they just talk to each other. And that's pretty much what I wanted to cover. So before we walk into a little bit of QA and questions, I want to thank you all for sticking around and listening. If you're a developer, we're looking for you. So we want people to actually help us, make this better. Constructive criticism, wishes, and everything else are super, super welcome. We assist a bunch of companies, large and small, and I'm pretty sure we can assist you. Of course, for custom projects, we can also provide consultancy and special packages to get things done. Bunch of links here. Take a screenshot, or I'm going to share this later. Just a few of the things, but I would say, starting from the github.com CIP capture repository, you can find almost everything, or you can look for previous presentations where we're talking about it. And with this, I would like to step into a little bit of Q&A to see what you guys think. Any questions in the chat that I've been missing so far?
Great stuff.
And take it to the finish line.
Lorenzo, yeah, you've brought that in for a nice early landing to give time for Q&A. Alexandra has been very busy on the chat, answering the things that have popped up. That's right, working very hard, Alexandra. We like to see that.
That's how we do it. We're a strong team.
Teamwork makes the dream work, they say. So that's great. But there is now a little bit of time if anybody would like to ask Alexander or Lorenzo a question. Do raise your hand, click the little raise hand button down at the bottom. That will highlight you in green, and then we will unmute you, and you can chat with either of these two fine gentlemen. Nice. I see you and Mike Harrison from Ring U simultaneously took a drink there at the same time. It's very nicely done. Yeah.
So yeah, there was a lot of material in there. So, we'll take any type of questions, also virtual ones. How are we going to do something that you didn't see? What's missing there?
I think what may have happened is that Alexander was so fast on the keyboard in the chat that he may have answered all the questions that would have been buffered up under normal circumstances, but he's dealt with them.
Well, that's efficiency.
Yes, very efficient indeed.
Can we actually unmute Alex? Oh, you're unmuted, Alex. Are you?
Yeah. Okay, I can.
Yeah. Absolutely.
Where are you joining us from, Alexander, today?
Still in Düsseldorf in quarantine.
Yeah,
we could not leave. Yeah, we could not leave, and we have to stay at home.
Okay, I'm with you. Yeah, you and Lorenzo are somewhat of a mystery to me. I never know quite where you're going to pop up from, in the nicest possible way.
No,
I think it is a compliment.
It is very much a compliment.
Yeah, but okay, it was a lot of questions about exactly external database, but yeah, the guys can use HEPSUP. In this case, can be connected to Elasticsearch, to Splunk, to any external database.
Right.
Yeah.
That's indeed really important, because we don't want to duplicate data, or we don't want to create liabilities. The more copies you have of certain types of data, the more liable you can be as well. So the HEPSUP integration is exactly designed with that in mind, and you can make HEPSUP agents that you never actually release to the world, right? So the license is fully compatible with you making agents that you maybe only use for internal, company purposes. Not necessarily everything has to be, publicly released. We understand that, some of the problems that we can solve with these are private ones, internal, dirty laundry.
Exactly. And another question was from Gerrit Jacobsen.
Yes, it looks like
he asked if
he's actually raised his hand, so he may have put something in the chat. But Gerrit, would you like to ask in person? You are unmuted. Yeah, you're unmuted as far as I can see. Okay. Maybe we've got some kind of audio issue with you there, Gerrit. Not altogether sure. I'll tell you what, Gerrit, if you're unable to speak, if you could just drop it into the chat, that would be great. Meanwhile, Paolo Baron has have you answered that in the chat there, Lorenzo?
I'm so efficient that I anticipate myself as well. It's usually 1 to 10 in the average load condition for agents in general. That's their usual profile. It's 1 to 10.
But also, let's say by default, with capturing free switch system, it's normal UDP. So the packet is already in user space. Duplicate this packet in user space over UDP, let's say, it costs nothing. It's
I thought we were talking about, let's say, processing power. Networking wise, of course, it's a different one.
Yeah, it's even processor power. It's normally exactly. It's normally asynchronous UDP processing, no controlling, nothing. Yeah, so it's peanuts.
But, our agents are designed to be invisible, low profile animals, so they expect to share a system with a real application that should have the priority.
I think, Lorenzo, sorry to interrupt you. I think it's Paolo asked about integrated capture system in FreeSwitch, because we have integrated agent inside in Sophia module, and normally the let's say main job is exactly copy packet from network stack kernel space to user space. And it's already done. So just you need to only duplicate this packet to HOMER, and again, it's you never take a lot of CPU on your system. And also using event socket to get some MOS information, jitter information. It's already the packet has been generated inside. You just need to make subscription to use passage and just duplicate this packet. So it's nothing.
Also, most things are stateless one-way streams. So they don't wait for a response. They don't have any counterpart that they need to care about. It's send and forget.
Yeah, and also if we're talking about, let's say, a system which, for example, it's a question also about yet another telephone engine, which normally it's SS7 mobile network PBX, let's say. It has a very good event system, which you can make subscription, take calls from event socket, and duplicate packets to HOMER. It's also cost nothing for you. And in this case, you can duplicate also Camel. You can duplicate SS7 packets encapsulated already in XML, as I know in Yet. Yeah, it's very very powerful. You can use Pastash in this case. And in worst case, if you don't have any system, you can use or Heplify or capt agent, and latest Heplify and capt agent supports AF packets, which normally it's let's say it's a packets version 3 in kernel space, and it's very powerful. It's use ring buffer, and it's also take less CPU. Yeah, Maxim, yeah, yet it's still alive. Yeah, I also thought it's dead, but no, it's still alive.
It's in the SAMS mode.
Yeah. No, it's because before it was SIP SS7, but as I understood, and maybe I'm wrong, they now make focus on mobile network with mobile registrations, virtual providers, and something like this. As I know, it's exactly a lot of virtual provider mobile operators use yet for such camel stuff, registration and roaming exactly procedure.
Nicely done, Alex. There's been other questions in the chat, but Lorenzo has swiftly jumped in. I popped you up into the top spot there because I thought it was a nice opportunity to get a quick screen grab with the pair of you smiling and holding your thumbs up in a Team Homer kind of way. Just
There
like
you go.
that. Go on, Alex.
Yeah, we can see.
High five. It's this side.
We've got that for you. That's great.
No,
okay. Now Ryan is asking whether there'll be a copy of the slides available from somewhere.
Absolutely, yes.
Yeah.
I'll post them on our GitHub, most likely.
Okay, that's great news. All right, I'm going to pop myself back into your slot there, Alex.
Let's go. Come back. Yeah. Thank you for this very good place.
Thank you, Alexander.
Yes, thank you. Oh, there you go. Casey did that for me. Thank you, Casey. Okay, well, it only remains for me to say thank you very, very much for coming along and talking to us about Homer. We always appreciate it, and always appreciate the work that you do in the community in general, because I know that you're also a key part of the OpenSIP Summit, which I've participated in on the odd occasion.
I love those guys. I can't be without them too long.
Yeah, indeed. We're all part of one big happy family, really, aren't we?
Absolutely, absolutely. As close as I know.
Great stuff. Okay, well, thank you, Alex. Thank you, Lorenzo. Let me just remind everybody that as we go into a break, we've got the Free Switch workshop with Luca, the third Italian in a row, I might point out, delivering a workshop in half an hour's time. That's at at 4 Central Time, 4 p.m. Central Time. So do make sure that you stick around for that, and that's going to be in the Free Switch workshop room. After that, we've got some social time, and don't forget we are going to be raising a glass and toasting the successful end of yet another ClueCon. So do stick around with us for that. But for now, we're going to close this session formally. However, I have a feeling that Lorenzo and Alexander will be sticking around in the room, and so there will be an opportunity to continue chatting with them. But let me say thank you once again, and we'll go into the break now. Bye-bye for now.
Thank you, David. Thank you, Free Speech. Thank you, Signal Wire.
Top class. You're very welcome.
Perfect.